When programming a part as complex as this, it's important to keep our tool and holder safe. Mastercam has the ability to apply holder checking, which means we can trim our toolpath motion or create tilt motion anytime our tool holder will interfere with the part. Generally speaking, this is a pretty easy thing to understand. We're basically trimming out any collisions, and we want to keep our toolpath moving without any collisions. Now there's one further thing we can do with holder checking. Let's see how it worked on the Nike. If we look at operation number 3 here, we can see that we have applied on the holder page collision checking. So here we can say apply a clearance to the shank and the holder, as well as on the bottom of the holder, and we're given a little red illustration of the clearance area that we're going to apply. So this red window is going to be collision checked against anything selected here in the machining region. Operation 2, 3, and 4 are essentially the same exact toolpath with different settings for holder checking. So we can see operation number 2 does a pretty good job. It leaves some open space. Operation 3 trims things up a little bit. And operation 4 does a beautiful job of getting all the way to the bottom of the part. Now this is all to do with holder checking. Let's look at operation number 2. In this case, we are not applying holder checking. We can see collision checking is turned off. If I open Analyze Toolpath on operation number 2, we can see that the tool starts out up here working on the very tip of the tool, and as it starts to fall down this waterfall face, the toolpath goes all the way down until we reach the very corner where the shank meets the cutting portion of the tool. Now, if we were to check out other areas of this part, somewhere down here we might see that there are some collisions between the holder and the part, because here we have turned off holder collision checking. If I do the same thing on operation number 3 and I apply the Analyze Toolpath, we can see that the motion actually is trimmed. See here we have a little bit of extra cutting in Op 2. Operation 3 is trimmed up a little bit. Analyze Toolpath on Op 3 shows basically we try the same thing. We get as far as we can on the cutting portion of that tool before we trim the motion because the holder or the shank of the tool gets too close. So in this case we can see that there's a bit of a gap between the contact point and the shank of the tool. This is equivalent to the offset we applied to the shank of the tool to keep that shank safe. The problem with this toolpath, even though it is safe to run, it does not complete the part. There's still a lot of air down here that is not being given a toolpath. Now if I run an OptiRough toolpath in here, I could easily remove this material, but I need to find a way to actually finish this material. Operation number 4 takes advantage of a little known setting to reach all the way down to everywhere an OptiRough toolpath could reach here. Now let me give you a little background on that setting before I show how to use it here. Let's take a look at another part just to show how this feature works. On level 5, I have a generic demonstration file where basically we have a waterline toolpath applied to 3 sides of a simple pocket. In this case, the waterline toolpath works around the wall. At the end of the cut, it retracts up and over this obstacle before entering its next path. If we open the parameters for this toolpath, we can see that we have a green drive surface as well as the red avoidance surface of this obstacle. If this was unselected and I regenerate this toolpath, Mastercam does not know that this obstruction is here, and we can see the rapid retract motion goes right through it. Now, of course, we want to avoid this obstacle, but let's say we're in a situation here where we can't retract the tool. What can we do here to keep the tool down and avoid this obstacle? Well, if we go over to the steep shallow page, down in the bottom, there is the contact area. Now, there's flute contact as our default setting. We also have tool assembly contact. And underneath, there's a checkbox called follow containment, which is grayed out until we change our setting. If I turn on tool assembly contact and I regenerate this toolpath, nothing's changed. Really, it's the same exact toolpath because in this case, the tool assembly doesn't come into contact with our part. The tool assembly being the tool holder in this case. But now, follow containment is an option. If I turn on follow containment and apply here, the toolpath will actually follow the containment boundary. Here we have already set a containment boundary. The tool follows that containment boundary without retracting, keeping the tool down and moving it over into its next pass. Up until the Nike project, that was the only time I'd ever seen this contact area actually used. But it turns out that tool assembly contact is an extremely powerful option that I'm going to use a lot moving forward. Let's back out of this toolpath and look back now at operation number 4. Now on the Nike, we can see operation number 3 safely avoids tool collisions into the part. Operation number 4 still avoids those collisions, but now it adds extra motion. And we can see basically the toolpath here is not even really touching the part as it works down this vertical wall. It's almost like the tool is being driven from an external force. Where operation number 3 keeps the shank and the holder safely from touching the part, operation number 4 actually uses the shank and the tool holder as a piece of the tool to drive tool motion. Now in this case, in operation number 4, we do have holder checking turned on with a shank clearance of 0.5 millimeters and a holder clearance of 1 millimeter. On the steep shallow page, we have enabled tool assembly contact. So in this case, the follow containment checkbox doesn't really have anything to do with what we're trying to accomplish. The tool assembly contact, however, that is the important part here. By activating tool assembly contact, I can see on the analyze toolpath that, again, the tool will step down. We are still using the cutting portion of the tool to drive this part. Let's hide some of these levels to clean up our display some. Now, as the tool propagates downward, we are actually using the non-cutting part of the tool to safely drive the tip of the tool. So here we are not colliding, the tool shank is not touching the part at all, but the tool tip is still working down toward the bottom of this cut. In fact, as we get all the way down here, eventually the holder is going to be starting to drive the tool motion, where the tool tip is going to be safely down in material, and the holder always stays a set amount away from our part. So we will never have a holder collision versus our part, but the holder is always being taken into account when driving the tool. So this is exactly the way that we can run an OptiRough toolpath to rough out this pocket, or everything we can reach at least from this angle, and then apply a waterline finishing toolpath and finish everything that we roughed, rather than by default leaving all these air sections that we don't drive the tool against. Turning on tool assembly contact allows you to reach much deeper and safely keep your holder and shank away from the part.